Hello students, welcome to chemistry class. Today we are going to study very important questions which are going to ask in NEV board exam for class 12. So I'm taking the topics here haloalkanes. We are going to do some very short questions, 2 marks questions. So first questions we have here, write down the structure. We have to write the structure and IUPAC name of secondary haloalkanes of C3H7X. C3H7X is the general formula for the compounds here. The haloalkanes is C3H7X. So what happens when the secondary haloalkanes is heated with sodium in presence of dry ether? We know that sodium in dry ether is a Wurtz reactions. There is a haloalkanes that react with sodium in presence of dry ether, which gives alkanes. So I'm writing first here IUPAC name and structure of C3H7X. So C3H7X is our general formula for haloalkanes. Yes. So here haloalkanes contain 3 carbons. So I'm writing here 1, 2, 3 carbon. We know that secondary haloalkanes mean haloalkanes bonded with that double bond that carbon which has 2 degree or secondary carbon. So in this carbon, first one is a 1 degree, second one is a 2 degree, and third one is a 1 degree. Yes. So this secondary carbon contain halogen is a secondary haloalkanes. So I'm writing here structure C here is X and here is C. Yes. So I'm putting here hydrogen, 3 hydrogen in this side, in the right hand side 3 hydrogen, and here 1 hydrogen. So the IUPAC name of this haloalkanes is 2 halopropane. 2 halopropanes. If we use here instead of X, we can use here ClBrI. Then we can write 2 chloro, 2 bromo, 2 iodopropane. Okay. So in second one, what happens when the secondary haloalkanes is heated with sodium in presence of dry ether? So we have secondary haloalkane. This is the secondary haloalkane. So I'm writing here CH3. Here is CH, and here is CH3. When this react with sodium, so this is the Wurtz reaction. So we take 2 mole of haloalkanes here, CH3, and here is CH. Yes. In Wurtz reactions, we take same haloalkanes that the double number of carbon atoms alkane is formed in the product side. So in presence of dry ether. Now here this sodium bonded with this halogen. Yes, this sodium bonded with this halogen. The bond is broken here. The bond is broken here. So here is also halogen. So this sodium form NaCl is a byproduct here to NaCl, but we have X, so we are writing to NaX. And remaining part we can add that part CH3, CH. Here is CH3, and here is CH bonded CH3 and CH3. So the name of this compound is 2,3 dimethyl butane. Dimethyl butane. Okay. So let's see another questions here. Identify the major product A and B in the following reactions. So we have reactions here. C2H5Br. This is the haloalkanes. Bromoethane. This is what? Bromoethane. This is bromoethane. When bromoethane react with magnesium, it gives Grignard reagent. So I'm taking here reaction C2H5Br. When react with magnesium in presence of dry ether, it gives C2H5MgBr. Okay, C2H5MgBr. So the name of this compound is ethyl. Name of this compound is ethyl magnesium bromide. Ethyl magnesium bromide. We also call this Grignard reagent. What? Grignard reagent. So Grignard reagent is very sensitive to water. So when it reacts with water, H2O, it gives alkanes, that is C2H6. Here in water there is a H plus and OH minus. So H plus bonded with this carbon and OH minus is bonded with here magnesium, because here magnesium contains positive charge and carbon contain negative charge. So the product is C2H6, that is ethane, and byproduct is magnesium hydroxide bromide. Magnesium hydroxide bromide. Therefore, the compounds A, major product A is ethyl magnesium bromide, and compounds B is ethane. So next questions. The next question is convert 1 chloropropane into 2 chloropropane. Okay. So first of all, we have to write the molecular formula or structural formula of 1 chloropropane. Yes, propane means 3 carbons. 1 means in one position there is a chloro. So the compound is CH3, CH2, CH2. This is 1 chloropropane. 1 chloropropane. Yes. So we have to convert 1 chloropropane into 2 chloropropanes. I am writing 2 chloropropane here. CH3, CH, here is Cl, and here is CH3. This is what? 2 chloropropane. So first of all, I am going to react 1 chloropropane with alcoholic KOH, which gives alkenes, that is dehydrohalogenation reactions or elimination reactions. Then the compounds form is CH3, CH, double bond CH2. Okay, halogen removed from this side and hydrogen removed from this carbon. Okay, so compound is propanes. So we can use here Markovnikov's or anti-Markovnikov's rules. So I am taking here HCl, here HCl, and if there is a Markovnikov's rule, okay, if there is a Markovnikov's rule, we apply here Markovnikov's. Markovnikov's rules. The positive part of the reagent bonded with that double bonded carbon atom which contain higher number of hydrogen, and negative part bonded with that carbon which contain lower number of hydrogen. Then product form is what? CH3, CH3, that is 2 chloropropane is formed. Yes, this is a conversion of 1 chloropropane into 2 chloropropane. So another question here, what happens when chloroform is exposed? Chloroform is exposed to atmospheric air. What happens? When chloroform is heated with silver powder, what happens? So first of all, we are going to react chloroform CaCl3. Chloroform when react with atmospheric oxygen in presence of sunlight, atmospheric air here, and nascent oxygen is formed here. So it gives phosphine gas, carbonyl chloride, CoCl2 plus HCl. And here is air and sunlight. And where CoCl2 is a phosphine gas, and it is very poisonous gas. Okay, and in second, heated with silver powder. So chloroform CaCl3 when heated with silver powder, it gives ethine, that is silver powders here Ag bonded with Cl here. How many Cl here total? Here is 3 and here is 3. So we have to take 6 mole of silver, and the compound form is here CH triple bond CH. So ethine is formed. Plus 6 AgCl. Next question here. Identify A and B in the following reactions. So we have here CH3, CH2Br. So bromoethane is given. Bromoethane. When it's heated with alcoholic KOH, we know that alcoholic KOH, in presence of alcoholic KOH. Bromethane is dehydrohalogenation or elimination reactions. Hydrogen and halogen is removed from this side. Yes, Br is removed from this carbon and hydrogen is removed from this carbon. So we can write the reactions here. CH3, CH2Br when react with alcoholic KOH, it gives CH2 double bond CH2. The name of the compounds is ethynes. So A is what? Ethene. And on ozonolysis A, so we are going to ozonolysis. The ozonide is formed here. Here C, it is ozonide formed like this. O, here O, and here is double bond between this carbon. So when ozonide is formed, this bond is broken, and here hydrogen, here is hydrogen, one hydrogen in this side and one hydrogen in this side. After ozonide formation, we are going to do zinc hydrolysis. Then this ozonide is break like this. Then aldehyde ketone, aldehyde ketone or aldehyde ketone is formed. So you can see here hydrogen is present with this carbon. So in both sides there is a aldehyde. And how many carbon here? One carbon. So you can write one carbon aldehyde, that is HCHO. And here is also HCHO. So you can write HCHO. So the compounds B is what? Methanol or formaldehyde. So IUPAC name is methanol. Common name is formaldehyde. Next questions here. Identify AgCN Y in the following reactions. We have AgCN when it reacts with magnesium diether. It means there is a presence of Grignard reagent, yes, RMgX. Because when something reacts with magnesium diether, it is going to form, it is going to obtain diethyl. And when Y react with CO2 and water, when react with carbon dioxide, it means addition of carbon here, addition of carbon in this Grignard reagent, and on hydrolysis it gives propanoic acid. It means here propanoic acid is CH3, CH2, COOH. Okay, CH3, CH2, COOH. There is a 3 carbon. There is a 3 carbon, and in this Y there is only 2 carbon because there is a carbon dioxide. So Grignard reagent when react with carbon dioxide, it forms if there is a 2 carbon in Y, then it forms 3 carbon. If there is a 1 carbon in Y, then it forms 2 carbon. So I'm taking here CH3, CH2, MgBr. Okay, I'm taking here halogen Br. So when it react with carbon dioxide C double bond O. Okay, when this react with carbon dioxide, there is a formation of, like we can say that this carbon bonded with this carbon, and this oxygen bonded with magnesium. Okay, MgBr is formed here. So the compounds is CH3, CH2, C double bond O, MgBr. But here is a single bond, yes, and here is double bond O. When this on hydrolysis, H2, H plus, then the compound form is CH3, CH2, here C double bond O, and here is OH, and the minor product is magnesium hydroxide bromide. So we find out compounds Y, that is ethyl magnesium bromide. Ethyl magnesium bromide. Ethyl magnesium bromide. And the compounds AgCN is here Mg diether. So compounds AgCN we can write here how many carbon? 2 carbon only, CH3, CH2, and Br. So name of the compounds AgCN is bromoethane. What? Bromoethane. So this is compound AgCN, and Y is ethyl magnesium bromide. Okay. Okay. Next questions here. Identify A and B in the following reactions here, and we have to give the IUPAC name of the compounds. So compounds A and B. First of all, we have to see here the compounds is iodoethane, iodoethane. And when iodoethane react with alcoholic AgCN, silver cyanide is a covalent compounds. So covalent compounds. So this there is a formation of isocyanide because this nitrogen bonded with carbon. So nucleophilic substitution reactions here: CH3, CH2, NC, CH3, CH2, NC. This is also called ethyl. This is also called ethyl isonitrile, ethyl isonitrile. And when it reduce with reducing agent lithium aluminum hydride, then it gives 2-degree amines CH3, CH2, and here is NHCH3. The name of this compound is N-methyl ethanamine. N-methyl ethanamine. This is a 2-degree amine. Okay. So compounds A is ethyl isonitrile and compounds B is N-methyl ethanamine. Next question: conversion where convert bromoethane to ethane. So first of all, I'm going to write the general formula for bromoethane: CH3 CH2 Br. This is bromoethane. And we have to convert bromoethane into ethane. Ethane is a CH triple bond CH. So we have to remove this Br and hydrogen. So we know that to remove the hydrogen and Br, we use alcoholic KOH, which is dehydrohalogenating agent. Then the compound form is here CH2 double bond CH2. Okay, this is formation of ethene. But we have to prepare here. Convert to ethine. So I'm again using here Br2 because this Br2 is addition reactions in alkene. There is addition reactions. So here is a formation of CH2, here Br, and here CH2Br. Okay, CH2Br is formed here. Now when the name of this compound is 1,2 dibromoethane. Yes, when it reacts with again alcoholic KOH, it dehydrohalogenation is occurs and the compounds ethine is formed. So we can easily convert bromethane into ethine. Yes, Br is removed from this side. Br is also removed from this side. The hydrogen, one hydrogen is also removed. So the formation of ethine here. So some other important chemical reactions from haloalkanes is some reactions I'm going to write here, like chloroform. To prevent chloroform from oxidation, we use 1% alcohol, 1% ethyl alcohol. Ethyl alcohol is used to prevent chloroform from oxidation. We know that chloroform, when oxidize or react with oxygen, it gives phosphine gas, which is very poisonous gas. So alcohol, ethyl alcohol is used. So it convert into the non-poisonous compounds diethyl carbonate. So I'm taking the reactions here. So here phosphine gas, C carbonyl chloride, C double bond O, Cl, here Cl. When it react with alcohol, here OH, C2H5 OH. Here is also C2H5 OH. Then this hydrogen bonded with this Cl, then HCl is formed. Again here from phosphine gas, this Cl bonded with hydrogen of alcohols, then it gives C double bond O, C2H5, and here is also what OC2H5. And the formation of here to HCl. This is non-poisonous. This is non-poisonous diethyl carbonate. Okay, this is non-poisonous diethyl carbonate. Therefore, chloroform is stored in dark brown bottle, or chloroform is stored which containing 1% ethyl alcohols.